Boom.
Good morning, ladies and gentlemen. Let's go ahead and talk about magnetic fields. A magnet has a magnetic field and symbolized by the letter B. Here is an example.
This looks like that pattern that you drew in your notes yesterday, right?
Yeah,
Except
it
there's
does.
something been added to it, and we'll talk about that more in a minute.
A magnetic field is a region of space around the magnet where it can exert a force. Do you guys remember yesterday when we asked you about what a field was? And you guys said a baseball field, a tomato field, a field of flowers. Right? it's just a field where stuff happens, right?
Yeah,
it's a region of space.
Yep, it's an area.
Yeah, it's just
Yep.
an area around whatever it is you're playing baseball, frolicking through the flowers, and so that's a region where that magnet can exert a force.
And see, this idea of the magnetic field explains how forces can be exerted at a distance.
Mm-hmm.
It's because the field around the magnet interacts. Well, we'll get to that more in a minute.
Okay. A compass detects the presence of magnetic fields. Here's my compass. Okay. And well, we said that it just faces north, right? The red. Okay, the red is the north-seeking end.
Pointing north,
Pointing
and
north.
the white is south.
Okay, and it detects the presence of magnetic fields. Now, I'm just gonna let it be like that.
Well,
get to
you
it.
got a bar magnet has a magnetic
well,
field
check
around
this
it.
out, right? If I bring this here, this is the north end, right? So that red side gets scared away.
Opposites attract.
This is the south end. Okay, that's what it looks like normally, right?
Yeah.
Okay. Okay.
They're fun to play with.
Yeah. All right. So a compass detects the presence of a magnetic field, and why is this exerting it? Why is this making it move? Because there's a magnetic field around it.
We can't see it, smell it, hear it, taste it, or anything like that.
But it's there.
But it's there. The magnetic.
Okay.
Oh, you know what?
Huh.
We've got this.
Oh yeah. Oh yeah. Okay, so check this out, you guys. So this is there's a magnet in here.
Not
It's
yet.
not in there yet. Okay. Oh well. So right now we've just got like some baby oil, some mineral oil or something, and then there's
Shake it up. Shake
and
it
then
up.
there's shake it up. Okay, and you've got like these iron filings in there. That's what that gray stuff is. And I'm gonna go ahead and just bloop, put that in there. Okay. And I wonder if I should.
See what's no? I got the screen.
Can you see it?
behind
Okay.
Yeah.
Oh, you see what's happening there? You can start to see the field lines, the magnetic field, the
Iron
lines.
filings that are in that oil are lining up with the magnetic field around the little magnet.
Okay, I'm gonna put it down. We'll come back to this. It looks really cool. It's becoming more and more visible there the longer it stays there. Okay. So magnetic fields interact to exert forces, and you could see where the magnetic field is here.
Yep.
Very cool. Okay, so opposite poles attract.
And we saw this yesterday when we had the north and the south facing each other.
Yeah,
And I like to think of that shape as a pumpkin.
it's totally pumpkin.
It
It's
looks
totally
like a pumpkin.
And again, looks just like what we saw yesterday, but it has those arrows on it. We'll talk about those later.
And it's like fingers are reaching out from one side to the other. Yeah,
Okay.
pulling each other's. And that's a picture of attraction.
Okay, same poles repel.
Yep.
And again, we saw this yesterday. We see that they're kind of like, a little being
Get
grossed
away
out
from
here.
me. You're so repulsive.
Yeah, okay. And you should have drawn something like this, but we didn't include the arrows yesterday.
So the shape of the magnetic field between same poles looks like that. And that's a picture of repulsion.
Okay, the Earth has a magnetic field. You don't say, right? That's why this compass does its thing. That's why this compass lines up. This is the north-seeking end. The red is the north-seeking.
Yep.
Okay, that's why it lines up like this. Let's see. So it says geographical North Pole.
Okay, well, the
Geographical
next one has a
south.
question here.
Okay, a compass lines up with Earth's magnetic field. We just said that, right?
So that's this. Also the bar magnet that you can't see there in the back. We can kind of see it back
Hold it.
there. Yeah.
Okay, a compass lines up with the Earth's magnetic field. if the Earth has a magnetic field, which it does, just like a big bar magnet, what kind of magnetic pole is near the North Pole? So this is a bar magnet, right?
So if there was a big bar magnet inside the Earth, what kind of magnetic pole is near the North Pole? Think about that for a minute. Now, let me go back here to this bar magnet I have difficulty locating. Okay, so there's the north-seeking end, and it's attracted to the north. So if there's a bar magnet inside the Earth, what end of that bar magnet would be at the North Pole?
I think that's a really good hint, Mr. Boykin.
Yeah, I know.
Let's take a look at our diagram here.
Opposites attract, so...
Okay, so opposites attract. So although this is the magnetic North Pole, it's really how do I say it?
The south pole of a bar magnet.
It's the south pole of the bar magnet. Yeah, because if you think about it, right, this red arrow is our north-seeking end.
Yeah.
Right. It's just like
It's
this
seeking
end
the north.
right there.
Yeah.
Right, that's hanging up in the back of our classroom like that.
Yeah.
And so it's a north-seeking. That means that this side of the Earth must be a south pole.
Yeah, because this
Or a south
compass,
pole magnet.
this compass is going to seek the south end
That's a really good demo.
like that.
So this end has got to be facing towards the magnetic south. So although this is the North Pole, it's really
The south pole of a bar magnet.
yeah, the south pole of the bar magnet. And again, this is geographically this is the south pole, but it's really the North Pole of the bar magnet.
That's weird.
You guys see that?
That's weird.
So it's kind of like everything you ever knew is flipped, but it's still north. You know, we still call it north.
Yeah.
Okay, so iron filings line up on the magnetic field, on the magnetic lines of force in the field.
So this pattern that we see is made up of lines, and they're called magnetic lines of force.
Look at
Yeah.
that.
That's what we've got going
Holy
on
cow, what
here.
did it look like on the video? Oh, good, nice. Okay.
Yeah, it's showing up.
Okay. So yeah, iron filings line up on the magnetic lines of force in the field. So you can see all the field lines on there. Super groovy. Okay. And then of course, here's a visual. Okay. The strength of the field is shown by how close together the lines of the force are. Oh, this is again perfect example.
So where would the magnetic field be the strongest here?
It would be up here and down here, right?
At either end.
Yeah, and you know what? This is a really good, because you can barely even see the lines, right? It just looks like a giant, like,
Yeah.
poof, right? And they're because they're so close in together there.
Yep.
And if you think back to yesterday's video with the iron filings over the bar magnets, right?
Yeah.
Then you remember that when we poured it over, then you remember that it was really dense right here, and then they were kind of a little bit thinner out here, right?
Yeah, so if I have a bar magnet, not getting much action here in the middle, but here I get some action. Okay.
Oh, because they're the strongest on the ends.
Yeah, because
there.
it's not very strong right here, a little bit, but it's
way stronger.
really
there.
strong at the end.
And so that means that the field lines are closer together there.
Yep.
Okay. All right. So the magnetic field is a vector quantity, just like velocity.
It's a vector
force.
quantity. So
Okay.
what does vector mean?
It has direction, magnitude, and direction.
Yep.
Okay. So the direction of the magnetic field is defined as the direction the north points on a compass.
Okay.
Okay.
All right. So that's so there's a magnetic field around this bar magnet. This compass, there's the north end. So the direction of the magnetic field here is in toward the south.
Oh.
And if we go around to the north end, it's defined as a direction that the north end of a compass points. So that would be out from the north. So out from the north into the south.
I think we have a slide for that. Here we go.
Oh yeah.
Okay, so what does that really mean? What did Mr. Boykin just talk about?
Sorry.
No, that was perfect. The direction is out from the north and into the south pole of a magnet. Did you guys see what he did? Right? It
Yeah.
literally, so we're coming out of the north. Okay, don't forget the red point is the north-seeking end. It's going out of the north, and then it kind of loops around, right? And then it goes into the south.
Yeah, and
Same thing on this side.
you have to have a definition. So the definition is the direction of north on a compass.
And so before we were talking about
it's coming out from this end. What end is that going to be?
This is the north side. It's coming out.
And it's going into the other.
Into the south.
That's the south side.
And that's, yesterday we drew this but without the arrows. Now we've got those arrows. And
You know, I just got a great idea. On your diagram that you made yesterday,
add those suckers in.
yeah, just decide which end is going to be north. Put that on the bar magnet, which end is going to be south, and put arrows on your lines of force.
Oh yeah, I like that. Okay, do that. Do that now. Okay. The interaction of fields shows attraction or repulsive forces. So, when the fields of two magnets interact, the directions determine attractive or repulsive forces. So, you know, we've got north and south.
So let's go out of the north and into the south. There's a natural connection that gives us attraction.
And then over here, we have out of the north and out of the north.
They're going in the same direction, so they repel.
Right, and so the direction that field flows in determines attractive or repulsive.
Yep.
Oh, wrong way. Okay. Okay. Pause the video. I want you guys to draw the field and label the types of forces.
So put two rectangles, put N on an S on one and N on the S on the other. And in the region in between here, draw the field and include the arrows and label what type of force. And remember, you got two options, attraction or repulsion. Go ahead.
Should I go ahead and just draw this real quick for them?
No.
Okay. All right. So hopefully you've done that. Here's my next one.
Oh, so now she changed the one on the left. So another pair of rectangles, this time SN in S, like this. And draw the field, including arrows.
And if you're stuck, look back at the slide from 2 slides ago.
Yeah, we just showed you. Come on.
Okay, and then tell me, is it attractive, is it repulsive, what's going on here?
You know, a question, we could play with these little colored magnets that we have right
I
here.
forgot about those. Oops. Okay, so we have these magnets. Oh, okay. And they're kind of strong. And so right now they are, stuck together. They're attracted to each other. Watch this. Okay.
Oh. Ooh.
Boom.
Ah. You did that so much better than I do. They're like floating. What's going on here?
What is going on? What's happening here?
Ooh, I have an idea.
Huh. Oh, nice.
Yeah.
Is it shaking back and forth?
Okay.
Oh, no. They act like, so it kind of acts like one bar, right?
Well, not now.
Not right now?
Not
Wait,
right
let me see
now.
what it looks like there, actually.
Oh, I'm sorry.
Okay. Oh, yeah, that's what I was thinking. It's going to be turning. Why is that?
Now, see, the thing is, so what can you tell, first of all, what kind of force is going on here?
There's repulsion in between here.
So what must be true about the poles in between?
So these
what happens
must
if you
be-
just dump them back out on the table again?
Okay. So
All right.
that means...
So now what can you tell me about the, now
right
use
here.
the compass.
Oh, yeah, now I use the compass. Okay, so I'll put this right here. Okay, so... Okay,
the
this must be the
north-
south-seeking end,
North
right?
end is pointing toward the south. Yep.
Okay. So we're gonna go. So we're coming out. Must be the.
Now just take one of those. Just pull one of them off and do the same thing with a compass.
Okay.
And you got to hold
Right
it.
there. Okay. Wait, which way do I hold it, button?
Well, I don't know. Move it around and let's see. So, right there.
Right there. Okay, right here. Oh.
So this must be the south end, and then move it around on the other side. Keep going, keep going.
Oh, that's the north
And that
end.
must be the north
Now,
end.
how did you know this was the south end?
Well, because what the compass is doing.
Yeah, the north arrow points to the south.
So here we've got these big long bar magnets with the one end is north and which one is south. But here it's like taking the bar magnet and squeezing it down to this little disc. Because, yeah.
Yeah, so this is like the south right here, right? And then we've sunken it down, and now this is the south side, and that's the north side. Okay.
And so when
I put it together like this, okay, so now when I put it together like this, if I float it around,
so all of them have their
this is the
north
south.
end on this end of each one of them, and each one of them has their south end on that.
Yeah, so it's kind of just like, it's just like this.
So put them back on the pencil again.
Okay. So basically what you're saying is so you're saying that this acts like this whole thing, but then when I
Right.
put it together, it still acts like that whole thing.
Yeah, every
right?
one of them is like an individual bar magnet.
Okay, let's see if I can get this right.
You got the wrong, yeah, okay.
Oh, do I have the wrong in there?
No, you're doing
Is it
good.
right? Okay. Ha, there we go. Woo! Okay, so these are floating.
So what force is that?
Repulsion.
That's repulsion. And what's
So-
required to make repulsion? I'll give you a hint.
The same charges. Okay, and let's see. This appears to be the north side.
Of the bottom one.
Yeah, because this is this is the north, and that would be attracted south. This is the south.
So make a
attracted north.
prediction. If that bottom one is the north, what's the top one? What's this side of the top one going to be? You got to go boom to boom to boom to boom. Make a prediction.
Okay, let's think through this actually. So if this is north, that means that must be south, right?
Yeah.
That must be south too, which means this is north, which means this is north, which means that's south.
Yes.
That's south, which means this is north. That's north, so this must be south.
So the top should be south.
Okay,
and
let's
see if it
see.
attracts the north end of the boom, boom, boom,
It
boom,
does.
boom.
Woohoo! You guys follow that? If you didn't, watch it again. Okay. All right. Wow, that was fun. Okay. Hopefully you got this. Here is for your homework. Please open your books to page 560 and do problems 1 through 3.
You can do this.